Okay, starting chapter 8, we're going to look at adding and subtracting polynomials today. And before we do that, we're going to do some definitions. First definition is a monomial. So that is a number, variable, or a product of a number and one or more variables with whole number exponents. Okay? Some examples of monomials would be just a whole number. You can do 3. You can have 2 times x. You can have a -5 ab squared. You can have a 1/2 times y. Okay, those are all examples of monomials. Examples of terms that are not monomials would be if you have a negative exponent. That is not a monomial. Also, you can't have a variable in the denominator. Why? Because technically that would be a negative exponent. That would be x to the -1. And you can't have something like x plus 4. This technically has what we call two terms, right? Separated by a plus sign. So you can't have things that are separated by plus and minus. A polynomial is basically, it can just be one term. It can be a monomial, or it can be a sum or difference technically of monomials. So now you could have x plus 4. You could have just one term, 3x squared. You could have, x squared minus 5x plus 2. Okay? Those are examples of polynomials. Poly meaning many. Then we're going to look at specific types of polynomials. So binomial, if you think about the first part of the word, right? That's going to be 2 monomials combined. So examples of binomials would be, let's say, y squared plus 4y. Possibly you could have a squared b plus ab squared. Okay, 2 terms. You could have a subtraction, so you could have n to the 4th power minus n to the 3rd power. Basically what you end up with here is you have one addition separating the 2 terms, or one subtraction sign separating 2 terms. Trinomial, again, look at the first part of the word. It's the sum of 3 monomials. So now we have 3 terms. So x squared plus 7x minus 1. Or you could have -2ab plus a minus 3b. Again, now when the trinomial, you're going to have 2 addition or subtraction signs. So here we have a plus and a minus separating our 3 terms. That negative sign in front of the 2ab doesn't count. But here we have a plus and a minus separating our 3 terms. Next, I want to look at what does the degree of the monomial, and then we'll look at the degree of the polynomial. So basically we just look at the exponents, degree meaning exponents. If we have multiple variables, we're going to add up all the exponents. In this case, 7y cubed, we look at the exponent. That has a degree of 3. Now, when you have a polynomial, we have multiple terms. So what we're going to do is we're going to do the greatest degree of any term in the polynomial. In other words, so here we have 3x squared plus 5x cubed minus 9x to the 5th. So look at each of the exponents. Compare which one has the largest. 5, so that's going to have a degree of 5. Okay, so example 1, we want to determine whether each expression is a polynomial. If it is a polynomial, we're going to find the degree and then determine whether it's a monomial, binomial, or trinomial. Okay, so the first one, 15x to the 4th. Is this a polynomial? Well, we don't have any negative exponents. It's got a coefficient, which is fine. So this is, yes, this is a polynomial. The degree, we look at the exponent, that's 4. And then the type, so notice there's no addition or subtraction signs involved. So this is one term. This is a monomial. Next one, we have 1 over x plus 2x cubed. But we have a problem here. One of the terms has x in the denominator, which makes it not a polynomial. And therefore, you don't have to figure out the degree or the type. We basically ignore those because if it doesn't qualify as a polynomial, it technically doesn't have a degree or a type. Next one, is this a polynomial? We have 1/5 y cubed plus y squared minus 9. So yes, this is a polynomial. What's the degree? So I look at the exponents. 9, technically that has just so you know, this is what we call a constant. Constants always have degree 0. So we want to look at what's the largest degree of any term. That's going to be the 3. So that's our degree. And then the type. So how many terms do we have? Well, we've got a plus and a minus separating 1, 2, 3 parts. So trinomial is when you have 3. Okay, next page, page 2. So next we want to look at standard form. I know there's a lot of definitions in here. You just want to make sure you understand when I ask, write it in standard form. What does that mean? So standard form is basically putting the polynomial, so when it is written, in order from greatest to least degree. Again, focusing on the degree, not the actual coefficients or numbers. So here's an example. It's in standard form because take a look at degrees. It goes from 5 to 3 to 2. And then technically this last term, remember I just talked about constants, would be a 0. So we always put the constants last. That's in standard form. Leading coefficient. So the leading coefficient, we basically look at the coefficient of the largest degree term. So if we're looking back at that last example, the largest degree term, that was 6x to the 5th. So in 6x to the 5th, 6 is the leading coefficient. Okay, write each polynomial in standard form, and then we're going to identify the leading coefficient. Okay, so take a look. Which one has the largest exponent? So that's going to be the first one. Then we have x to the cube. That's going to be our second term. Then minus 21x squared. That's going to be our third. And lastly, because that has a degree of 1, that's going to be the last one. So let me rewrite it. So 3x to the 4th plus x cubed minus 21x squared. And although there's no sign in front, we have to recognize that that's a positive x that we're going to be adding. So I'm going to put a plus x. Then I want to identify what's the leading coefficient. That's a 3 because that's the coefficient in front. All right. If you want to try the next two on your own, go ahead and do that. You can pause it. The largest degree is c to the second power. Make sure you include that -5. That's the coefficient. Then minus 3c, then plus 4. So the leading coefficient is going to be -5. And lastly, okay, so we have negative 3x to the 4th plus 1/2 x plus 7. and the leading coefficient is going to be -3. Okay, like terms. So we've already worked with like terms. This is when we have the same variable or combination of variables with matching exponents. So some examples would be -7x and 5x. Or maybe you have a 3a squared b and a -a squared b. So you can have a combination of variables as long as they are exactly the same. So x and x. So in other words, I cannot combine like an x and an x squared. Those are separate terms. These both had an a squared b, so you could actually combine those, which is what we're going to do in this. These are going to be the last set of examples. We're going to find each sum or difference. And then just a quick reminder to distribute the subtraction sign. So if you notice a subtraction sign in between, we have to subtract everything in that second polynomial. Okay, so we have 4y plus 5 plus a -7y. So I'm just going to write that as -7y plus a -1. So that's really just -1. And then we look, what can we combine? So I have 4y and a -7y. That will give us a -3y. And then I'm going to combine the constants. So plus 5 and a -1 will combine to give us a +4. And then we just leave our answer like that. We can't combine those. Next, okay, so I have 4k squared plus 8k plus 2. And this one has a subtraction, so I'm basically distributing. So it's going to be a -2k minus 3. Now, 4k squared, I don't have any other term with a k squared, so I'm going to leave 4k squared by itself. Next, I see a plus 8k and a minus 2k, so I'm going to combine those. That'll be a plus 6k. And lastly, I have a plus 2 and a minus 3, so combine those, and that's going to give me a -1. And that's my answer. Okay, next one, I have a 5a squared plus 6a plus 2. And this is a subtraction, so I'm going to subtract everything in this second. So that's going to be a -7a squared. Now, minus a -7a will make this a plus 7a. And then minus a positive 5, so that'll just be -5. Again, if you want to pause it and try these on your own and check to see if you got them correct, that's fine. 5a squared and a -7a squared gives us a -2a squared. Remember, we're combining the coefficients. Plus 6a plus 7a is going to give us a plus 13a. And lastly, I have a plus 2 and a -5 gives us a -3. Now, when it's addition, none of the signs change, so you technically don't even have to rewrite these. You can just go right to combining when it's a plus sign. But if you want to rewrite it, that's fine. You have that choice. I'm just going to go and combine them since it's a plus. So let's see. I have 4u squared and 3u squared. So that's going to give us 7u squared. I have a -2u and a -u. Remember, technically there's a 1 in front. So that's a -2 and a -1, which will give us a -3u. And -3 and +4 is going to give us a +1. Okay, last two have several polynomials, so here's what I'm going to do. I'm going to rewrite it, especially since I see the minus sign. So the minus sign means I'm going to have to, right, distribute that minus sign to everything. Now the first one never changes. Notice there's no subtraction sign in front. So we always just rewrite that first one. So I have 6f squared minus 7f minus 3. Then I'm going to distribute that minus. So I'm going to have minus 5f squared minus negative 1. So that's going to become plus 1. Then minus 2f. I have a third polynomial here, so I'm going to distribute that minus. So that's going to be minus 2f squared minus negative 3, so that's going to make it a plus 3, and then minus f. Okay, now I have a bunch of different terms, but that's okay. I'm going to just match up. So let's look at the f squared. So there's 6f squared minus 5f squared minus 2f squared. So 6 minus 5 would be 1, minus 2 would be a negative 1. So that would be a negative f squared. Next, I'll look at, I have a negative 7f, a minus 2f, and a minus 1f. So negative 7 and negative 2 would be negative 9. Another negative 1 would make that a negative 10f. Next, I have a minus 3, a plus 1, and a plus 3. So that's going to just end up as a plus 1. And then the last one here, I notice these are just plus signs. So that actually means nothing is going to change here. So you don't have to rewrite it without the parentheses, but if you want, you can. I'll just rewrite them real quickly. Okay, so let's see. I have a combination of x times y, so 2xy. Let's see, do I have any others? Yes, right here. So I'm going to combine those. I think that's all I have. So 2 and a minus 3 will be a negative 1xy. Next, let's take a look. I got 6y. So let's look for any other terms that just have y. Looks like a plus 6 and a minus 8 will give us a negative 2y. Okay, then we have negative 3z, a plus 6z, and at the very end I have a plus 1. So let's see, that's going to give us negative 3 plus 6, so that's going to be 3, plus 1 will give us a plus 4z. And then lastly, running out of highlighter colors, let's see here, I have a plus 4x and a plus 3x, and I think that takes care of everything there. So plus 4 and a plus 7, or sorry, plus 4 and a plus 3 will be a plus 7x. And then again, we just leave those because none of these have any other like terms.